lectures just so you can watch them again. So yeah, got some normal syllabus stuff. You guys can read through this. The prereq for this class is college algebra. Hopefully you have a pretty strong background in algebra. The business calc, kind of a hard class for students to pass. Has anyone taken this class before? I'll do my best. Really, it's the algebra that students struggle with. They can get the calculus part. It's just like simplifying their answers or factoring that students mess that up. But so our book is the 10th edition of Applied Approach of Calculus. You guys can just use the ebook. Your student fees have paid for your access to this ebook. So if you have a hard copy, you can return that, try to get some money. Our ebook is, if you go to WebAssign, it's right here, this ebook. So this is what the book I'm going to follow along. Yeah.
It let me rent for free a hard copy through Engage Online.
That's cool.
Yeah, it shipped.
That's awesome. I know sometimes I prefer to have a actual book. The book's nice. I think it has all the odd answers in the back. So that's always nice. That way you can practice some problems on your own. But you don't technically need the hard copy. So just letting you guys know that. There is another book. This is a free book in case you want to see extra examples or do extra problems on your own. Right there. Calculators, I'm going to let you use a non-graphing calculator on all of the tests. You're welcome to use a graphing calculator on your homework. That's fine with me, but a non-graphing calculator on the tests. What else? You guys can read through this later. This is my only business calc class. So if you send me an email, just let me know what class you're in, at least for the first couple weeks. I'll try to learn your names as soon as I can, but just say you're in my business calc class and whatever your question is. This semester, I'm going to start doing attendance quizzes. So every class, including today, there will be a quiz at the end of class. If you are not here, you cannot make up this quiz, but I will drop the lowest 4 at the end of the semester. So these quizzes aren't a huge chunk of your grade. I just want to get you guys here and get you studying a little bit every day. Hopefully it will help our pass rate. So I got the attendance quizzes. We have 2 types of assignments. We have written assignments and online assignments. The online assignments are through WebAssign, Cengage. It should all be open now. So you just go to Blackboard and hit this WebAssign online assignments and you can get started there. WebAssign assignments are due the day of the exam. So you have a while to complete those. I do recommend you guys work a little bit every day. Try not to get too far behind. Our other type of assignments are written homework. Written homework is due the next class period. I don't have all of them posted yet though. Normally I teach this class Monday, Wednesday, Friday. I haven't taught this class on a Tuesday and Thursday in a long time. So like all my stuff is, I have to like figure it out how much I'm teaching each day. So kind of a lot of work for me now. But so I have the first couple. So if you're ever gone, you can find the next assignment on Blackboard. You click the blue assignment link. You don't have to print these out. You can do it on regular sheet of paper if you're gone. And if you're gone, you need to make sure you turn in the assignment that's due that day. You click on the black assignment link and you can upload a picture. But I'm hoping you're here every day. I prefer to grade paper. So just hand in your paper. So questions about that? Okay, what else in my syllabus? I don't accept late written homework, so I'm gonna drop, I think, the lowest 2. That's my other class, this one. Yep, I'm gonna drop the lowest 2 written homeworks, so no late homework is accepted. We have 5 exams and a final exam. I have the dates at the bottom. In general, I don't let students miss an exam and retake it. You have to have a pretty good excuse. Yeah. So here's my grade breakdown. Attendance quizzes is just a small chunk of your grade. Written homework, online homework, our 5 exams and our final. And then my grade breakdown. So questions so far?
Is the final included?
Yes. Yeah, final is over everything in this semester. I think it's on that Tuesday, May 9th. It is 2 hours long, so eat a good breakfast there. Ends at almost 1 o'clock. But here's our schedule. I think we'll probably stay pretty on track. I'm going to try to get a little bit ahead. That way we can have a review before each exam. A lot of chapter 1 is review though. There's one more thing. The math lab is in Jabara Hall, building with the square windows. That's free tutoring. So I would go there, bring your homework, ask for help. I think the Office of Student Success does tutoring as well. They always change it up on me. I can never remember, but I'll try to get some information about that. Other questions you have for me? So we got online homework, do the day of the exam, do a little bit each day. We got written homework, do the next class period, attendance quizzes. Yeah. I'm going to record these lectures. The video link will be in Blackboard. If you do miss class, you can watch it, or if you just want to watch it again. I guess let's get started. Let's see which class you are. On Thursday, I do have a longer attendance quiz. The math department in the past has been pretty generous with business calc, kind of whatever the instructor wants to do goes. This semester, they're kind of cracking down. We're supposed to make all of our exams the same and final exams the same. So they have this like prereq quiz I'm going to hand out on Thursday for you. But in general, our quizzes are pretty short. Just so you know, on Thursday, if you want to prepare your algebra skills. Let's go ahead and start. 1.1 is on the Cartesian plane and the distance formula. That Cartesian plane is when I intersect an x-axis and my y-axis, and I'm dividing it into 4 quadrants. Quadrant 1, 2, 3, and 4, going in a counterclockwise rotation. Might seem familiar. This is my Cartesian plane. I have this positive x-axis, this positive y-axis, and my quadrants 1, 2, 3, and 4. So each point is called an ordered pair. X represents the distance horizontally from the origin. Y represents the distance vertically from the origin. That origin is that 0, 0 point. You guys remember all this? What if I wanted to plot the point 3, -1? Where would that go? I would go over 3 and down 1, so that would be in quadrant 4. So 3 and down 1. Okay, just making sure. So let's plot these points. I got 1, -2. Where would that go? Left 1, up 2. How about 3, 4? Over 3, up 4. 0, 0, that's my origin. Where would 3, 0 go? Over 3, up and down, none. And then -2, -3. So plotting points. The next part of this section is finding the distance between 2 points. The distance between 2 points is given in this formula here. If I have a point x1, y1, that's my first point, and a second point x2, y2, to find the distance, we can think of it as Pythagorean theorem, or you guys can just memorize this formula. So if I have one point here, this is its x coordinate, this is its y coordinate. I have another point, maybe it's here. Here's its x coordinate and its y coordinate. Find the distance here. I could find the distance between the x values, taking x2 minus x1, square it, and it needs to add with the distance between the y values, taking y2 minus 1 squared, and then square rooting it for this distance formula here. So this is a formula that you'll probably have to memorize. In general, I don't let students use a note card on the exam. So this will be a formula you'll have to have memorized. Let's go ahead and do an example. We'll put it over here. Find the distance between spell. Let's do -1, 5. And how about -2, let's do 4. Or no, let's do 6. Trying to make it so we have to simplify a square root. -2, 6. So I'm going to write out that this is my first x value and this is my first y value. And this is my second x value, my second y value. Find the distance between -1, 5 and -2, 6. So I'm going to write out the formula. It's a big square root of x2 minus x1 squared, and I add y2 minus y1 squared. So I'm going to take -2 minus a -1, square that, and I'll have to take 6 minus 5 squared. So order of operations, I need to do what's inside the parentheses first. So what is -2 minus a -1? Yeah, -1. And then I'll have 1 squared. -1 squared is 1. 1 squared is 1. So I end up with the square root of 2. Questions about that? Yeah.
If it's like a bigger number, like the square root of 4, do you want us to still write it as the square root of, or do you want us to simplify it and just have a number?
So depending on what your answer is, a lot of times we can simplify. Square root of 4 is 2. If my answer was maybe the square root of 50, to simplify this, I want to think what's the biggest perfect square that goes into 50. A perfect square is like 4, 9, 16, 25. 25 goes into 50 2 times. And then I'm going to square root the 25 and get 5 square roots of 2. So we do want to simplify these kinds of square roots. What's the biggest perfect square that goes into 50? It's 25. Maybe we should practice a few of these. How would I simplify the square root of 27? 9 and 3. And then I square root the 9, square root the 3. So I get 3 square roots of 3. How would I simplify the square root of 500? What's the biggest perfect square that goes into 500? 100. 100 is a perfect square. 100 times 5 is 500, so I'll have 10 square roots of 5. So I'd square root the 100 and get 10. So 10 times the square root of 5. You guys remember doing this kind of stuff? It's okay if you're a little bit rusty. We just want to think of the biggest perfect square that divides into those numbers. So our example that we had was just 2. So that's no perfect squares divide into 2. So we'd leave it like that. The last part of this section is on the midpoint formula. The midpoint formula is where I add my x coordinates and divide by 2, and I add my y coordinates and divide by 2. So if I'm given 2 points, x1 comma y1, x2 comma y2, we want to add our x coordinates, divide by 2, add our y coordinates, and divide by 2. So I have an example right here. These 2 points, -3, 7, +1, -1. Let's find the midpoint. Someone's squeaking. Thought it was me, but it can't be me. So I'm going to label this is my first x, this is my first y, this is my second x, and this is my second y. Let's just write it right underneath this formula. I'm going to take -3 plus 1. I'm going to divide it by 2. And then I'm going to take 7 plus a -1 and divide it by 2. This midpoint is an ordered pair. It's a point. So I'll have -2/2 and then 6/2. This simplifies to -1, 3 is my midpoint. While this is up here, let's go ahead and find the distance between this point, these 2 points. So let's write out that distance formula again. X2 minus x1 squared, and I add y2 minus y1 squared. Let's find the distance between those 2 points. So I need to take 1 minus a -3 squared, and I'm going to add -1 minus 7 squared. So order of operations, I need to do what's inside the parentheses first. So what is 1 minus a -3? 4. What's -1 minus 7? -8. So I'll have 16 plus 64. So that's 80. What is the biggest perfect square that goes into 80? Maybe 16 goes into 80. 16 is a pretty big perfect square. I don't know what 16 times what is 80, so I'm going to take my calculator. 80 divided by 16 is 5. So 80 is the same as 16 times 5. So I'm now going to write this as 4 square roots of 5 is that distance. Questions? All right, so that's all that's in the first section. First section's kind of small. Let's go ahead and go on to section 2. Section 2 is a little bit longer. Section 2 is on graphs of equations. So graphs of equation, section 1.2, to find x-intercepts, let y be 0 and solve the equation for x. So that means we're plugging in 0 for y. To find our x-intercepts, we plug in 0 for y. To find our y-intercepts, we let x equal 0, and then we solve for y. Right? If I think of a graph, maybe something like this. My x-intercepts, these are x-intercepts, are where y equals 0. We want to know the x value. My y-intercept is where x equals 0, and we want to know the y value. So I have this example right here. It says find the x and y-intercepts of the graph. I have y equals x cubed minus 4x. So let's start with the x-intercepts. X-intercepts, I plug in 0 for y. Solve for x. So 0 equals x cubed minus 4x. How do I solve for x? Factor, what can go into both of those terms? An x. I'm left with what if I factor out an x in front? And then can that factor further? Yeah, that's x plus 2, x minus 2. That difference is squares. So my solutions are 0, -2, and +2. My solutions for x, 0, -2, and +2. So my x-intercepts are the points 0, 0, -2, 0, and +2, 0, are my x-intercepts. Questions about finding those x-intercepts? It also says to find the y-intercept of this graph. This one's not too bad at all to find the y-intercept. To find the y-intercept, we plug in 0 for x. So I'd get out just y equals 0 minus 0. So our y-intercept is 0, 0. But we kind of already saw that from our x-intercept, 0, 0. I got a couple more. Find the x and y intercepts. You guys ready? Let me know if I'm going too fast. So our next example is y equals x squared minus 2x minus 3. Find the x and y intercepts. I got y equals x squared minus 2x minus 3. Let's start with the x-intercept. So we want to plug in 0 for y. Solve for x. So if I plugged in 0 for y, I'll have 0 equals x squared minus 2x minus 3. How do I solve for x if it looks something like this? I don't want to move the 3 over. I want to factor this. This factors into x, maybe minus something, plus something, another x. You guys remember how to factor? I need to think of two numbers that multiply to be the C and add to be the B. What two numbers multiply to be -3 and add to be -2? -3 and +1. So these are my factors now. So what are the solutions? +3 and -1. So my x-intercepts are the points 3, 0 and -1, 0. Questions on factoring, how we went from here to there? I want to think of numbers that multiply to be the C and add to be the B. multiply to be the C, add to be the B. So that's my x-intercepts. What are the y-intercepts of this graph? -3. The y-intercept is when we plug in 0 for x. Plug in 0 for x. So I'll have 0 minus 0 minus 3. So I'll have -3. So that's the 0.0 -3 for our y-intercept. Questions? Do I have another one? No. Maybe let's do one more. I can make it up on the spot. Let's find the x and y intercepts of, how about y equals x squared? Let's do plus 3x minus 10. Find the x and y intercepts. Find the x and y intercepts. So let's start with x-intercepts since that's what we've been starting with. My x-intercepts is when I set y, sorry, I keep on hitting over there. Let's find that x-intercept. So plug in 0 for y. Solve for x. So I'm going to set this equal to 0. What does this factor into? Perfect. Right, I needed to think of two numbers that multiply to be -10, add to be +3. Questions on that? So what are my solutions? Those are my factors. What are my solutions? -5 and +2. So that must mean my x-intercepts are -5, 0 and 2, 0. Those points that we would plot. What's the y-intercept here? How do you think I should write that though? 0, -10 is my y-intercept. Right, an x-intercept and a y-intercept are points that we want to plot, so we want to write them as a point. So questions on factoring and intercepts? It's okay if you're a little bit rusty, but this is something that you're going to have to do like every day of this class is factor. So we'll practice though. The next part of this section is on points of intersection. An ordered pair that is a solution of two different equations is called a point of intersection of the two graphs. So here we have two graphs, just two equations, y equals x squared minus 3 and y equals x minus 1. Any ideas what this graph looks like? A parabola. Yep, it looks like a parabola. It's just shifted down 3 units. Any ideas of what this graph looks like? A line and it's going up the page. Line going up the page, maybe something like this. So if I want to know the points of intersection, what we want to do is set one equation equal to the other and solve for x. One equation equal to the other and solve for x. So let's do this for this example. I'm going to set x squared minus 3 equal to x minus 1. And I want to solve for x. X squared minus 3, I'm going to set this equation equal to this equation. So how do I solve for x now? I want to set one side equal to 0 and factor again. So I'm going to subtract my x over, and I'm going to add my 1 over. What happens when I add my 1 over? I get -2. And then what does this factor into? what two numbers multiply to be -2, add to be -1? -2 and +1. So my solutions are 2 and -1 for X. Questions about that? So those are my solutions for X, right? X is 2 and -1. What are my solutions for Y? If I wanted to plot these points, how do I find the Y values? To either one, I'm going to plug in the X values to either one. I'm going to use the second one just because it's a simpler equation. So 1 point when X is 2, the Y value is going to be 2 minus 1, so 1. And the other point when X is -1, the Y value is going to be -1 minus 1, so -2. So I got 2 points, 2, 1, -1, -2. These are my points of intersection. Section, squeeze it in here. Points of intersection. I set one equation equal to the other. I had to set one side equal to 0 and factor again. And then to find the Y value, we want to plug those X values back in to either equation. Questions on this example? Okay, a common business application involves a point of intersection. It's called break-even analysis. When sufficient units have been sold so that the total revenue has an offset the total cost, the sale of a product has reached its break-even point. When I set my total cost equal to my total revenue and solve for X, that's my break-even point when cost and revenue are the same. When cost and revenue are the same. So in general, we call our cost equation capital C, and we call our revenue equation capital R. X is the number of units made and sold. X is the number of units made and sold. So maybe I'm making coffee mugs. If I'm selling 20 coffee mugs, X would be 20. So here I have an example. It says a company manufactures a product of $0.65 per unit and sells the product for $1.20 per unit. The company's initial investment to produce the product was $10,000. Will the company break even when it sells 18,000 units? How many units must the company sell to break even? So a company's making a product, maybe it's coffee mugs again. It makes the product at a cost of $0.65 per unit, or 65 cents. So this is part of the cost, right? It says cost per unit. This is part of my cost. Now it has an initial investment of $10,000. This is also part of our cost. Now I want to come up with an equation for my cost and an equation for my revenue, and I want to set them equal to each other. So my cost to make this product, if X is how many products I'm making, the cost equation is going to be capital C. It's going to be 0.65 times X, and then I'm going to add 10,000. This is going to be my cost equation. Right? If I'm making 20 coffee mugs, I need to take 65 cents times 20 to find how much it's costing me to make those coffee mugs. And then I had that initial investment of $10,000. So this is my cost equation. What's my revenue equation going to be? If I'm selling each of the product for $1.20, revenue is the amount the company is bringing in. 1.2x will be our revenue. right? How much is the company making? There, you need to take the price times how many you're selling. So $1.20 times 20 if they're selling 20 of them. So I need to set my revenue equation equal to my cost equation to find my break-even point. So questions about coming up with these two equations? All right, so I'm going to set 0.65x plus 10,000 equal to 1.20x. And I want to solve for x now, right? Find a intersection point. I want to solve for x. So one equation equal to the other and solve for x. So how will I solve for x in this type of problem? Nothing is squared, so I won't need to factor. I just need to get everything with x on one side. So I'm going to subtract the 0.65x. I'm going to get my calculator out. I'm going to take 1.2 minus 0.65, and I got 0.55. I subtracted this term over. Questions about that? What will my last step be to get the x by itself? Divide by the 0.55. 10,000 divided by 0.55. I got 18,181.818181. So this is how many of the product they need to sell. Let's go ahead and round this up to 18,182 units. They need to make this many units, sell this many units to break even. So the question before, so how many units must it sell to break even? They need to sell this many units. So the company hasn't broken even if it's only selling 18,000 units. We need to get past that amount of units to break even. Questions on this? Kind of our first word problem here. A couple more business applications. Two types of equations that economists use to analyze and market are supply and demand equations. A supply equation shows the relationship between the unit price, lowercase p, of a product and the quantity supplied x. The graph of a supply equation is called a supply curve. A typical supply curve rises because producers of a product want to sell more units when the price is higher. So this lowercase p is price, and x is still the number of units. Right, if I'm making coffee cups or calculators, x is the number of things we're making. Lowercase p is the price. We do have a capital P, that's profit, but lowercase p is the price, which is kind of hard to see on the screen, but that's a lowercase p. So my supply curve rises. Another type of curve is our demand curve. The demand equation shows the relationship between price and the quantity demanded x. So the graph of the demand equation is called the demand curve. A typical demand curve tends to decrease as the quantity demanded with each price increase. So demand is going down as the price is, well, kind of flip-flop from what we were thinking. But if the price is increasing, the demand is decreasing. If the price is increasing, the demand is decreasing. So one goes up and one goes down. Usually we want to figure out where they're equal. Where is the supply curve equal to the demand curve? So both of these equations would be given to you, and then you're supposed to set them equal to each other and solve for that point of intersection. So, and this is called the equilibrium point, where our demand curve and our supply curve intersect. equilibrium point. So let's go ahead and do an example. So here are the demand and supply equations for an ebook reader. Are P equals 195 minus 5.8x, and P equals 150 plus 3.2x. Where P is the price in dollars, and X represents the number of units in millions. Find the equilibrium point for this market. So all they're wanting us to do is set one equation equal to the other and solve for X. Set one equation equal to the other and solve for X. So I want to set 195 minus 5.8x equal to 150 plus 3.2x. I want to solve for X. So in this example, X isn't squared, so I don't need to set one side equal to 0 and factor, right? Like we did earlier in the class. What do I need to do in order to solve for X? Get everything with X on one side, everything that doesn't have an X on the other. So let's add 5.8x over 3.2 plus 5.8 is a 9. I have 9 x's on this side. What should I do with the 150? Subtract it. So I got 45. And then what will I do to get the x by itself? Divide by 9. So I got 5 equals x. So this is my x value. What should the price be? X is 5. What will lowercase p be? I need to plug that in. Either equation, let's just use the second one. What's 150 plus 3.2 times 5 to get that price? Because in general, when we're asked to find a point of intersection, we want to know both coordinates. So 3.2 times 5 and then add 150. I got 166 should be the price. And that's in dollars. So 5 units, 5 million units, since it said it was in million. And $166 will be the equilibrium point for this market. Questions on solving for X? Okay, that's the last bit of 1.2. Let's go ahead and start on 1.3. 1.3 is on lines. Look at this. Usually we're going to try to get to 2 sections a day, but 1.1 was super short. So 1.3 is on lines, plane, and slope. The simplest mathematical model for relating 2 variables is the linear equation, y equals mx plus b. What does m stand for? Slope. What does b stand for? The y-intercept. So when x equals 0, we can see that b is our y-intercept. I have a positive slope if my line's going up the page, negative slope if my line's going down the page. So, seem familiar? Good. So m is the slope, b is the y-intercept. Vertical lines, maybe this one you don't remember, is just x equals a number, like x equals 2 is a vertical line through the x coordinate 2. Vertical lines have undefined slope. Vertical lines. What would a horizontal line be? A constant, y equals a constant, like y equals 5. What would the slope of a horizontal line be? 0. Let's sketch these. How do I sketch a line? Let's do part A. Where do I start? What do I do? on part A. One this way or this way? Up one. And then what do I do with that 2? Up 2 over 1 this way, right? The slope is 2 over 1. Questions about that? How do I sketch part B? Straight line, straight horizontal line, y equals 2. How about part C? A, B, C. What do I do for part C? I would probably get my y by itself, subtract the x on both sides. That way it's in that form. Subtract my x from both sides. So it is a negative slope, and I do start at 2. I'm going to go down 1 over 1. Questions on graphing our lines? So using slope is our ratio or a rate in real life problems. If x and y have the same units, then our slope has no units, it's a ratio. If x and y have different units of measure, then the slope is a rate or rate of change. So slope usually has a pretty big application in real life problems. So rate or rate of change, ratio. So here I have an example. A manufacturer company determines that the total cost in producing X units if a product is 25X plus 3,500. Describe the practical significance of the y-intercept and the slope. So the slope is 25, and this is my cost equation. So what does 25 mean in terms of this problem?
It's the cost to produce a unit.
It's a cost to produce 1 unit. My slope is 25. So it costs $25 per unit. To make this unit, it costs $25 per unit. Another word is, this is called marginal cost. Cost per unit, $25 per unit. What does the 3,500 stand for? That's my y-intercept. The initial investment. It's constant, right? It doesn't change as x changes. That's my constant fixed cost. Fixed cost. To find the slope of a line given 2 points, that's my m. We need to take the change in y over the change in x, right? Slope is rise over run. So to find my m, I need to do y2 minus y1 and divide by x2 minus x1. Find the slope of a line. So another formula that maybe you need to have memorized if you don't have it already. Find the slope of a line given 2 points, x1, y1, x2, y2. And then to find the actual equation of the line, I use the equation y minus y1 is our slope times x minus x1. This is called point slope form of the equation of a line. So another guy that you might need to memorize. So let's do some examples. Find our equation of a line. Let's just start at part A. Find the equation of the line that passes through these 2 points. That's the directions. I just didn't add it in here. Find the equation of the line passing through both points. So let's start with part A. So I got 2 points, -2, 0, and 3, 1. I want to find the equation of the line, so I want to know its slope and y-intercept. Let's start with what's the slope between these 2 points. So let's call this our first point. Let's call this x sub 1, y sub 1, x sub 2, y sub 2. How will I find the slope? Yep, y2 minus y1 over x2 minus x1. So I'm going to take 1 minus 0 over 3 minus a -2. So I'm going to take 1 over 5 for my slope. Questions about that? Now, the equation to find our line, that point intercept form is y minus y1 is our slope times x minus x1. Find the equation of the line. So I'm going to plug in our slope, and I'm going to plug in our first point for the y sub 1 and the x sub 1. So I'm going to take y minus 0 equals our slope 1/5 times x minus a -2. You guys see what I'm doing there? I'm plugging in x sub 1 and y sub 1. Y minus 0, that's just y. Here I have 1/5. This will be x plus 2. And then I want to go one step further. That way I can see exactly what the y-intercept is. I'm going to distribute my 1/5. So I'll have 1/5 x plus 2 over 5 is our equation for this line. Questions on that? Let's do part B. Let's find another equation through these 2 points. Let's do part B. So we just did part A. I'm going to erase this. Part B, what's the equation between these 2 values? I have -1, 2, and then 2, 2. So I like to label my points. This is my first x. This is my first y, y sub 1. This is my second x. This is my second y. So my slope is going to be 2 minus 2 over 2 minus a -1. So I get 0 over 3. What's 0 divided by 3? 0. So my slope is 0. What does that mean about my line? I have a horizontal line. So horizontal line, what will my equation be? And what constant do you guys think it will be in this example? 2, because that's the point it goes through. Y equals 2 is my answer. Right? I knew it was a horizontal line because my slope was 0. It has to go through that y value, that common y value, 2 and 2. Which one is my vertical line, C or D? D, right? Both of those x values are 3. So D, my equation is x equals 3 for D. That's a vertical line. I have 3, 4 and 3, 1. Questions about that? Let's go ahead and do C. Let's erase all this. Let's do C. Let's find the equation between 0, 4 and 1, -1. So let's find the equation between these. So let's call this our first point. So our first x, our first y, this our second x, our second y. So what is my slope? You're too fast for me. I'm going to take -1 minus 4. I'm going to take 1 minus 0, so -5 over 1. So -5 is our slope. So good job there. And then I want to find my actual equation for my line. This is just my slope. So I use this formula, my point intercept formula. I'm going to do y minus, y sub 1 was a 4, equals my slope -5, x minus 0. So I got y minus 4 equals -5, x. How will I get the y by itself? I need to add the 4 over. So -5x plus 4. Questions on that? I added my 4 over. Okay. The next part of this section is on parallel and perpendicular lines. Two non-vertical lines are parallel if and only if their slopes are equal. Two non-vertical lines are parallel if and only if their slopes are equal. Two non-vertical lines are perpendicular if and only if their slopes are negative reciprocals of each other. Negative reciprocals of each other. Sorry, that's a little small. Parallel, they have to have equal slopes. Parallel is equal slopes. Same slope, parallel lines, they're rising, going up and over the same. Perpendicular, I have negative reciprocals. Negative reciprocals are opposite reciprocals. Maybe you learned it that way. One's positive, one's negative, right? One's going up the page, one's going down the page. Reciprocals, like 2/3 and 3/2 reciprocals. Ready to do an example? Let's do it. Find the slope-intercept form of the equations of the lines that pass through the point 2, -1. And I got two parts. I want to pass through this point, and I want one to be parallel to this given line. And then I want to do another problem where I'm perpendicular to this given line. So we got two-part problem. Let's start with our parallel part. I want to go through this point and be parallel to this line. So let's figure out, what is the slope of the given line? What is the slope of the given line? Let's write out our given line and find its slope. Given line is 2x minus 3y equals 5. How will I find its slope? What do I need to do with the 2x? I need to get the y by itself, so I'm going to subtract the 2x over. And then I'm going to divide each side by the -3, or I divide each term by the -3. So I have positive 2/3 x minus 5/3. This is my given line. So the slope of the given line is positive 2/3. So if I want to find a parallel line, its slope also has to be positive 2/3. And I want it to go through this point. So what will I do next? Plug in the numbers, 2, -1, this is my x sub 1, y sub 1 into that formula. Y minus y1 is my slope, x minus x1, using that point slope form. So I'm going to plug in -1 for my y sub 1. I have my slope is positive 2/3, and I got 2 for my x sub 1. Questions about what I'm doing? Y minus a -1 is y plus 1. What will I do with my 2/3? Distribute. How do I take 2/3 times that -2? What does that become? Yep, -4/3. And then what will I do with my +1? I need to subtract the 1 over. How do I take -4/3 and I -1? Think of it as -3/3, so I have -7/3. Right, think of this one as 3/3. So -4 minus 3 is -7. Questions on that? We got some fractions there. So that's the first part of this problem, is find the line that is parallel to this given line passing through this point. The second part is find the line perpendicular to this given line that passes through the same point. So this is going to have opposite reciprocal slope and a whole different y-intercept, So when I'm doing part B to this problem, I'm going to write down for part B, my slope is opposite reciprocal. So what will the slope be? -3/2. And then I'm going to start over with my y minus y1 is my slope times x minus x1. It's going to have a whole different y-intercept. I don't just flip the y-intercept or anything like that. I have to restart the whole problem. I'm still wanting to go through that point to -1. So I'm going to have y minus a -1, so +1, my slope times x minus x1. So questions about this? I do need to distribute the -3/2. What will happen when I distribute -3/2? It becomes positive what? 3. And then what will I do to get the y by itself? Subtract the 1. 3 minus 1 is 2. So this is my answer to part B. Questions? Feeling familiar with the lines? I think that's it. I was looking at your written homework right here. I want to do one more x and y intercept problem, something a little bit more complicated since I didn't have it in the notes, and then I'll give you this quiz. Suppose our equation is y equals x squared plus 3x over x squared minus 9. Find the x and y intercepts. Find the x and y intercepts. This is section 1.2. Kind of skip the harder kind of problem. Let's start with x-intercepts. Find the x-intercepts. I plug in 0 for y. And then we need to factor. This factors into what? How can I factor my numerator? I need, okay, we could multiply our denominator over. Multiply my denominator over. So I have x times x. Oh, I'm factoring for you. I don't want to do that for you yet. So I multiplied my denominator over. Questions about that? How do I factor this? I would take out an x, and I'll have x times the quantity x plus 3. So what are my solutions? 0 and -3. The only thing that we need to make sure of, because this problem was a little bit harder, right? I have this denominator. One of the big rules in math is I can't divide by 0. If I plugged in -3, into the denominator, I cannot do that. I can't plug in -3. I'd have 0 divided by 0. So my only x-intercept is 0, 0. Right? I want to check the domain. How I originally was thinking that we would do this is we would factor the numerator and factor the denominator. So my only x-intercept is the factor in the numerator. Okay. So the only x-intercept is 0, 0. Right? -3 can't be an x-intercept because we can't plug -3 in. We can't divide by 0. Let's do one more. Make sure you guys really understand it. What's my y-intercept before I move on? This is my x-intercept. What's my y-intercept? The same, 0, 0. Okay, let's do one more. Find x-intercept and y-intercept. Let's do, how about x squared minus 36 divided by, how about x squared plus 7x plus 6. Find the x and y intercept. Find the x and y intercept. So let's start with x-intercept. To find the x-intercepts, I'm setting 0 equal to y, plugging in y equals 0. What would you guys do next? I would factor, that's what I would do. What does my numerator factor into? X plus 6, x minus 6. What does my denominator factor into? X plus 1, x plus 6. So I can't plug in a -1 for x or a -6 for x. So those can't be x-intercepts. So what would my x-intercept be? If it can't be -1, it can't be -6, what would my x-intercept be? +6 from this factor. A +6 from this factor. Right? I can't plug in a -6 or a -1, so my x-intercept is +6 from this factor. So I'm going to write that as an ordered pair, a +6 is my x-intercept. That's a 0. +6, 0 is my x-intercept. Questions on that? What would my y-intercept be on this problem? I plug in 0 for x for my y-intercept. I plug in 0 for x. I'm like squeaking. So I got -36 over 6. So I get -6. How should I write this? 0, -6 is my y-intercept. Okay, let's stop here. I have a short little quiz for you. You can't use your phones on the quiz.